Chronic inflammation is connected to nearly every major disease category that shortens and diminishes quality of life. Heart disease, type 2 diabetes, cancer, arthritis, depression, cognitive decline. The link between chronic inflammation and these conditions is well established in the research. What is less commonly understood is that the food you eat 3 times a day has a measurable and consistent effect on your body's inflammatory state. Fruits, specifically, contain a range of plant compounds that have been studied in clinical trials for their effects on known inflammatory markers. 5 fruits stand out for having particularly strong evidence behind their anti-inflammatory effects. Here is what each one contains, what the research shows, and the specific mechanisms through which they reduce inflammation. The first is strawberries. Strawberries are one of the most studied fruits for anti-inflammatory activity. Their bright red color comes from anthocyanins, a class of polyphenols that inhibit the activity of pro-inflammatory enzymes and have been shown to reduce levels of C-reactive protein, one of the most reliable blood markers of systemic inflammation. CRP is used clinically to assess inflammatory burden and predicts cardiovascular disease risk independently of other markers. One well-designed study found that consuming the equivalent of roughly 2.5 servings of fresh strawberries daily for 14 weeks produced significant reductions in inflammatory markers and improvements in insulin sensitivity. Insulin resistance and chronic inflammation are tightly linked, each driving the other in a feedback loop. The fact that strawberries showed measurable improvement in both simultaneously reflects the polyphenol content working through multiple pathways rather than a single mechanism. Fresh strawberries are the most nutrient-dense form, but frozen strawberries retain their polyphenol content well and are a practical year-round alternative. The second is kiwi fruit. Kiwi fruit delivers an exceptional concentration of vitamin C, with 2 medium kiwi fruits providing approximately 142% of the recommended daily intake. Vitamin C is a potent antioxidant that directly neutralizes free radicals, the unstable molecules that damage cells and trigger inflammatory responses. It also protects immune cells from oxidative damage during immune activation and supports collagen synthesis, which is relevant for connective tissue and joint health. Beyond vitamin C, kiwi fruit contains polyphenols, flavonoids, and about 4 grams of fiber per 2 fruit serving. The fiber component feeds beneficial gut bacteria that produce short-chain fatty acids with documented anti-inflammatory properties. Early research suggests that regular kiwi fruit consumption may support healthy gut microbiome composition and reduce gut inflammation, which is increasingly understood to be connected to systemic inflammatory levels through the gut immune axis. The skin of kiwi fruit is edible and contains additional fiber and compounds not found in the flesh, making whole fruit consumption more nutritionally complete than peeled. The third is apricots. Apricots contain beta-carotene, the orange pigment that the body converts to vitamin A. Beta-carotene functions as an antioxidant in its own right and also serves as a precursor to vitamin A, which is required for immune system regulation and has direct anti-inflammatory activity. Beta-carotene intake is associated with reduced oxidative stress and lower markers of inflammation in population studies. Apricots also contain a range of flavonoids including catechins, quercetin, and rutin. Quercetin is one of the most extensively studied anti-inflammatory compounds in the plant kingdom. It inhibits the production of histamine and pro-inflammatory cytokines, reduces oxidative stress in tissues, and has been studied specifically for its effects on inflammatory conditions, including allergies and cardiovascular disease. The combination of beta-carotene and multiple flavonoids gives apricots a broad-spectrum anti-inflammatory profile that makes them nutritionally distinct from many other fruits. Fresh apricots at peak ripeness have the highest polyphenol concentration. Unsulfured dried apricots are a practical alternative for non-seasonal availability, though they are higher in sugar per gram. The fourth is rhubarb. Rhubarb is technically a vegetable, but functions culinarily as a fruit because of its tart flavor and traditional use in sweet preparations. Its stalks contain polyphenols, flavonoids, and phenolic acids that contribute to its anti-inflammatory activity. Red rhubarb varieties are particularly concentrated in anthocyanins, the same class of compound responsible for the anti-inflammatory properties of berries and cherries. Rhubarb is also one of the better plant-based sources of vitamin K, with 1 cup of diced rhubarb providing approximately 30% of the recommended daily intake. Vitamin K plays a role in regulating inflammatory pathways and is essential for proper blood clotting and bone mineralization. Its anti-inflammatory properties are independent of its coagulation functions and have been studied in the context of cardiovascular and bone health. One critical safety note: rhubarb leaves contain high concentrations of oxalic acid and are toxic. Only the stalks should be consumed. The fifth is cherries. Cherries have one of the strongest evidence bases among fruits for anti-inflammatory activity. They are rich in anthocyanins, quercetin, camphorol, and catechins, a combination of polyphenols that work through complementary pathways to reduce inflammation. Research has linked cherry consumption to reductions in C-reactive protein, improvements in post-exercise muscle recovery, and better management of joint health conditions. The gout research is particularly specific. Some studies have found that cherry consumption may reduce the risk of gout flares by up to 35%. Gout is driven by uric acid crystal deposition in joints, which triggers an intense local inflammatory response. Cherries appear to help regulate uric acid metabolism and reduce the inflammatory cascade that follows uric acid accumulation. Tart cherries have the highest concentration of the relevant compounds and have been most studied in athletic recovery and joint health contexts. Sweet cherries are also effective, with slightly lower compound concentrations. Frozen tart cherries and unsweetened tart cherry juice are practical options for people who want the anti-inflammatory benefit outside of cherry season. The broader principle underlying all 5 of these fruits is the same one that drives all evidence-based anti-inflammatory dietary guidance. Plant pigments, the compounds that give fruits their colors, are not decorative. They are bioactive molecules that evolved in plants as defenses against oxidative damage, UV radiation, and pathogens, and that produce measurable anti-inflammatory effects in human biology when consumed regularly. Eating a variety of deeply colored fruits, not just the same one every day, exposes your body to the widest possible range of these compounds and the widest possible range of anti-inflammatory mechanisms. No single fruit and no individual meal produces dramatic changes in inflammation. What produces meaningful change is the cumulative pattern of dietary choices across hundreds of meals over weeks and months. Including these 5 fruits consistently in that pattern is one of the most evidence-supported and most practical ways to shift the balance in the right direction. New videos every day covering the nutrition science that gives you specific, actionable information about your health. Subscribe and stay with us. There is a practical consideration worth adding about form and preparation. Many of the anti-inflammatory compounds in fruits are water-soluble or heat-sensitive, which means how you consume them affects how much benefit you receive. Fresh fruit retains the full complement of active compounds. Frozen fruit, because it is flash frozen at peak ripeness, preserves most of the polyphenol content and is nutritionally comparable to fresh for anti-inflammatory purposes. Cooked fruit loses some vitamin C and heat-sensitive polyphenols, but retains fiber and more heat-stable compounds, including many anthocyanins. Fruit juice, even freshly pressed juice without added sugar, removes most of the fiber and concentrates the natural sugars, which reduces the blood sugar benefit of whole fruit and removes a key component of the prebiotic effect. Eating whole fruit or using frozen fruit in smoothies where the fiber is retained is consistently the most nutritionally complete approach. Combining fruits from this list with other anti-inflammatory foods amplifies the overall effect. Adding strawberries to a breakfast that also includes oats and nuts, combining kiwi fruit with leafy greens in a smoothie, or serving apricots alongside fatty fish creates a meal with multiple converging anti-inflammatory mechanisms rather than a single one. The compounds in different plant foods often work synergistically, and dietary variety is consistently associated with better health outcomes than the same food eaten every day, regardless of how beneficial that food is individually.